In this presentation, we'll be demonstrating the Allegro integration to Teamcenter for both designs and libraries. We'll start with the schematic tool with the embedded Teamcenter menu and doing an initial save. In Allegro design entry, we have a schematic open. If we take a look at our custom variables, you can see we have some variables defined for description, power, and rating that we'll be mapping to Teamcenter. Also have them shown in our title block. Within design entry, we have embedded Teamcenter menu. And within that menu, we have functions to search for and open designs from Teamcenter into Allegro, to save those designs, save them as to a new part number in Teamcenter, to increase the revision level, to check them in, check them out, and to initiate workflows on designs and component parts. For this new design, we will do a save as to pull new part numbers in Teamcenter for the design. The top level is the PCA, or printed circuit assembly. You can configure the integration to automatically assign part number and revision, or you can manually assign using the Assign ID button, or enter a value. You can also change the names of items just by typing in the dialog. We will generate a bill of material for every project from a parts list from the design and a schematic visualization file. In the Allegro integration to Teamcenter, we create a separate part number for the schematic data. So all of the schematic data will be in its own part number and separate data object. We can change the name for the schematic part number. If we look under it, we see the data object, the data container for all the schematic data. We'll also create a part number for the PWB printed wire board, or the bare board, so that we can represent the board itself within the bill of material. With the base configuration, we can now hit Finish and save the design to Teamcenter. An optional but common configuration that is done is known as derived data. Derived data consists of two parts. The first being the ability to create extra part numbers for a design during the save process. In my example, I'm creating two additional part numbers, one for the drawing, one for my manufacturing data. As many additional part numbers as you wish can be created, and they can be named whatever you choose. They are all related up to the project, just as the schematic and board part numbers are. The second part of derived data is derived data sets. It's a way to take output type files and save them to their own data objects in Teamcenter. We have several examples here. One is my layout drawing, my board drawing, schematic drawing. All these are PDFs. And then under my manufacturing, I have Gerber and ODB++ and a manufacturing drawing. Whatever files you wish and their location in the project is completely configurable. Now we can hit the Finish button and the design will be saved to Teamcenter with the options we selected. Now let's review the schematic design within Teamcenter. In Teamcenter, we'll use a quick search to find the project we just saved. We'll open the project and see the overview and the bill of material. Open the bill of material by itself, and we can see the board part number. So we can represent the bare board in the bill of material, as well as all the components that make up this design, along with their reference designators. And if we have multiple instances of a component, we pack the reference designators. Go back to the overview. We can then go to the attachments and see the layout PDF that we saved to the project. To see the full structure, we'll use our Relations browser. We can see the project item with the board and its board drawing. We can also see the schematic part number with the schematic data set and the visualization file. Notice that everything is related up under the project. We also see some other of our output data, such as the layout drawing, and underneath our optional items, some additional output data such as ODB++, manufacturing drawing, Gerbers, and the schematic drawing. We can open the schematic item to see more details about it. You can see the attachments that we saw in the relation view. We can also see the properties that we mapped from the schematic, the description, power, and rating. So we're mapping properties between Teamcenter and the Allegro design. Now let's look at the layout tool with its embedded Teamcenter menu and do a save. So in Allegro PCB Designer, we have our PCB layout open. We have a Teamcenter integration menu embedded into it also, allowing us to open, save as, check in, check out, initiate workflows, just as we did in the schematic side. So we'll save as our PCB layout. All the part numbers are set as we define these from the schematic side. We have a PCB layout data object containing all our PCB design files, as well as our PCB visualization file. Have the same derived data options, and we can go ahead and finish, and the PCB layout side will be saved to Teamcenter. So now let's look at the layout design in Teamcenter. So in Teamcenter, we'll do a quick search for the project as we did before and open it up. We'll still see the same bill of material in the overview. But if we go to our attachments area, we can see that we now have the PCB board design data object containing all our PCB design files, as well as the PCB visualization file. PCB information is saved underneath the project, and the schematic design information is saved under the schematic object. Next section, we'll be looking at the visualization capabilities within Teamcenter. Let's first open up the schematic visualization. You can highlight the schematic visualization file and have it open in visualization. So we see the schematic in the visualization tool. We had multiple sheets they would be represented. We can look through the assembly tree, find R2 for instance, and it will be centered and highlighted for us. And if you find R2, then you of course have to find D2. So there's diode 2. You can also search for and highlight nets. So if we want to find out where a net is, we can click on it, see the net with the pins. Now let's open up our PCB visualization file. So we can see the PCB layout. We can see the layers of the PCB that we can turn on and off. We can see the circuits as we did on the schematic side. So if we find a component on the PCB side, it will be highlighted same as we did in the schematic, as well as nets also. You can also flip the board to look at the other side of it, see what components are mounted back there. Now, since we have the schematic and the PCB visualization open, we can split our screen, see them both at the same time, and cross-probe between them. So now if we choose a component, we'll see it centered and highlighted in both the schematic and the PCB layout. You can also do markups on either the schematic or the PCB layout. We're going to zoom up on the PCB and do some interrogation so we can measure between chip to edge or chip to chip. So here we're doing a quick measurement from chip to edge here. And we'll go ahead and measure chip to chip distance. And we can also measure net lengths. So we can pick 2 pins of a net and have the traversed distance shown. Also have standard markup tools such as text and arrows. We can communicate design information. These markups then can be saved against the visualization file in Teamcenter to record the design review. In this section, we'll be showing our capabilities for saving variant designs. So within Allegro design entry, we have a design open. If we look at our variant editor, we can see 3 variants, V1, V2, V3. We've got components in them that do not populate conditions applied to them. So C1, R1, and U1, and then C2, R2, U2, and C3, R3, U3, based upon the variant. So some simple variant conditions and 3 variants. So if we use our embedded Teamcenter integration menu and do a save as on this design, we'll see the same menu that we did before with the printed circuit assembly at the top level. The bill of material. So the bill of material at the PCA level is the master bill of material without any variant conditions applied. We'll also see the visualization file, the schematic, part number, the schematic data set with the schematic data contained into it, the printed wire board or bare board, the derived data, so the extra derived part numbers, as well as the output data that we defined. It's the same as the non-variant project. The difference is we pull a separate part number for each defined variant. So you can see 3 part numbers with the names that were defined in the variant editor. So contained in the variant part numbers is a bill of material. This bill of material is the BOM as populated for that variant. We can also place derived data sets underneath the variants. In this case, I've got a layout drawing for each one of the variants. So now with our structure defined, we can finish and the design will be saved to Teamcenter. Now let's review the variant design in Teamcenter. In Teamcenter, we'll use a quick search to find the design. We'll open up the variant project. So at the variant project, you can see the bill of material. At the project level, again, the bill of material is the BOM without any variant conditions applied. So if we sort by reference designator, we can see C1, C2, C3, R1, R2, R3, and U1, U2, U3. So if we go to our relations browser, we can see the structure. Again, we have the project at the top level with the schematic and the board reporting up to it. The schematic containing the schematic design and visualization. But we also have the 3 part numbers for the variants, V1, V2, and V3. If we open up the variant, so here we'll select variant 1 and open it, we can see the bill of material as populated for variant 1. So again, if we sort by reference designator, we can see that C1 is missing, as well as R1 and U1. So this is the variant bill of material for variant 1. If we open V2, and again sort by reference designator, we'll see the bill of material for variant 2 is missing C2, R2, and U2. So each of the variant part numbers contain a bill of material that is the BOM for that variant. Now let's open a design from Teamcenter into Allegro. So in Allegro design entry, we use the embedded Teamcenter integration menu to open a design. So we get a Teamcenter window open that we can either navigate to our designs, or we can use the quick search to find the design. So we'll enter search, find the design. We can open it up and look at the information contained into it. So the bill of material and any attachments. And then we have the choice of whether to open it for modification, we mean check it out, or we can open for reference to just open it without checking it out. So we'll open for modification. The design is downloaded and opened up into Allegro Design Entry. We look at our custom variables. We can see the project ID, revision, and title have been filled out with information from Teamcenter, showing the bidirectional transfer of properties. So we'll zoom up on the title block and see the properties used there. And so we can use our Teamcenter menu to save the design and continue working on it, or we can check it in and be finished. So we'll check it in. Part numbers are already set as we open this design from Teamcenter. We'll go ahead and check the design in. Let's look at initiating design workflows. So in Allegro, go to our Teamcenter menu and initiate a design workflow. So we're going to submit this design to a design approval workflow. We'll enter some information and go to our next dialog. We assume that the open project is the one we want to submit, so it's added as a target. You can also search for and find other designs that we wish to add as targets. So go ahead and finish, and this design will be submitted to a design approval workflow. We want to check the status on it. We can use our inbox to go to our workflow tasks, and we can see that it is at Larry Marvick's desk at the design review task. Going now to the library integration, let's do a part search in Allegro and initiate a part workflow. So in Allegro, we're going to try to add a new component. So we'll do a quick search in our capacitors class and look for a 10 picofarad capacitor. So we can't find any, so we need to request a new part to be added to the library. So we'll use our Teamcenter workflow, part workflow, to initiate a part request workflow. So we'll enter information. We can also attach existing components either from the design or from Teamcenter to use as reference or as part changes. And we can also attach files to the request to help describe the component we want. We'll finish and the request will be submitted. And we can use our inbox to check the status of the workflow and see that it is at the librarian review stage. Let's look at our Allegro library and how we set up EDA Gateway to communicate with it. So in Allegro Library Explorer, you can look at the library. You can look at the capacitors class and look at its part table. If we look at the part rows, we can see all the parts that we have in our capacitor class, as well as all the fields that we're defined in the library. We can do this with any of the classes. So if I look at the resistor class, for instance, we'll have the same type of thing. If we look at its part table, you can see all the resistors as well as the fields defined for the resistor class. Going to Teamcenter EDA Gateway for Library, we can see all the components that are defined in the Cadence Allegro library. We can also see Teamcenter information about these components. These were created from the Allegro library. Through our configuration for EDA Gateway, we're pointing to the Allegro library. We then map all the attributes and classes between the two systems. Once we have the mapping correct, we can then save the library to Teamcenter. We do this using the Export Library to Teamcenter command. When that is done, the parts are created, classified, and the properties transferred to Teamcenter. So if we go through our classification structure and go to our capacitor class, you can see the properties defined, such as value, tolerance, voltage, etc. If we open up one of the components, you can see all the properties defined for that component that were imported from the Allegro library. So if we look at our part table and the Team Center window, we can see the value, tolerance, pack type, JDEC type, etc. have been mapped from the Allegro library to Team Center properties. So we want to make a change to a component, so we're going to revise the component in Team Center. So we'll go to Revision B, make whatever edits we want to, and save those edits. We can use the EDA Gateway tool to synchronize that information out to the Allegro library. We can use the Team Center Synchronize from Team Center to push any changes from Team Center back to the Allegro library. Let's continue with our new component creation and export that information to Team Center. So Librarian has a new task. So we'll look at the task and see that it is a library review to search to see if there's an existing component that will meet the needs. So we'll use a save search, go to the classification, so for capacitors, and see the properties for the capacitor table. We'll go ahead and try to find a 10 picofarad capacitor. None exist. If some did, we could look at them and select several of them and can compare between them. But no components exist per the requirements for the new component. So the librarian will go back to the task and approve it. So the next task is to create the part. So we'll need to create the part, attach any necessary documentation to it. So to create the part, we're going to go into Allegro, into the Library Explorer. So we'll go to our Passives Cap class. And for this example, we're just going to edit the part table, understanding that there are more things that we'll need to do in Allegro to define a new component. But for this example, we're just going to add one to the part table. So we'll go to our part table and add a component. So we'll enter all the information for this new component and save the table. So now the component has been added to Allegro. So in Team Center Gateway, we'll do a refresh and we can change the listing to just show us the parts that don't exist in Team Center rather than trying to find the component in the list. We'll just show non-existing components. We'll see the capacitor. It does not exist in Team Center yet. So we'll use our Team Center export library to Team Center and see the component will be created, we'll finish, and the component will be uploaded to Team Center. Now let's continue with the Team Center create part workflow. So in the workflow, we've created the new part. So if we use our save search and go to our Allegro capacitor class, we can search for the value of 10 picofarad. And we'll see the new component. This component was created from the EDA Gateway export to Team Center, so the component came from Allegro and is in Team Center with all the information attached to it. And so we'll go ahead and attach some documents that we need, compliance forms and data sheets, just by dragging and dropping them onto Team Center. And then we'll go ahead and copy this component so that we can attach it to the workflow for further approvals. So we'll attach the new component to the workflow and complete the workflow. So now if we look at the new capacitor that's created, you can see it has an approved status and is ready to be used. Lastly, let's do a part search in Allegro to show the new component. So in Allegro, we'll go to Add a Component. Go to our capacitor class, enter our search parameter, and see our new component. We can add that to our design. So the component exists both in the Allegro library and in Team Center.